Carlos Ramirez, owner of NBS Audio in Roselle, New Jersey, and Daytona, Florida. So, you guys have been reaching out to me, asking me if the battery video is done. Yes, it's finally done. It took me a while to edit the video, and it took me weeks to run this test because I wanted to make sure I tested all these batteries thoroughly. I wanted to make sure I gave every single battery a fair shot, and I wanted to make sure it was an apples to apples comparison because some of these batteries have different chemistry. They do better under different situations. For example, the sodiums will outperform some of the lithiums if you are able to charge them up to 16 volts. A lot of the competition guys are running sodium batteries and running 16 volt chargers so they can get a full 2 volt advantage over their competitors. Then the lithium batteries will only charge up to 14 and a half, but they will play longer and maintain their voltage longer. Then I did a lithium video 4-5 years ago. Video got a lot of views. I've had a lot of questions. A lot of stuff has changed in the past 4 or 5 years. Battery technology has changed, battery chemistry has changed. My experience with lithium batteries has increased. Pretty sure we do the most lithium battery installs on Harley out of any shop in the United States. It's not bragging, we do a lot of lithium upgrades, especially on the 2024s. We do a lot of 5,000 watt amps. Obviously, you can't do that kind of an upgrade on a bike. With any given time, we have 20 lithium batteries in stock ready to go. So we do a lot of lithium here at the shop. So I was able to test all these batteries. There was 2 batteries in particular that you guys asked me to test that I did not include in the test. One was because the battery capacity wasn't high enough, so it wouldn't have been fair to put that battery up against these big batteries. The other is that the other battery is the first one you guys asked me to include was NOCO battery. NOCO makes a great product. I like the way NOCO advertises and sells their batteries. NOCO is known for making really good jump packs and chargers, so of course their lithium battery would be really good. It's a drop-in fit, has a great warranty, available everywhere. You can even buy it at AutoZone, but it is not an audio battery. The reason I say this, it's only an 8 amp hour battery, so this is stronger than the factory battery. It's only $200. The reason it's $200, it's because it's very small capacity. So 8 amp hours at 200, most of these batteries are 30 amp hours. So 8 and 8, 16, double again is 32. So then to get 32 amp hours of capacity would be $800 on a NOCO battery, which would put you right at what the top line lithiums go for, $800. So we had a client here that I was helping with a tune, and I felt bad because he had the NOCO under the seat. He had 2 in the tour pack, and I had to explain to him that it's great that you upgraded the capacitance of your bike, but one 30 amp hour under the seat would give you more power, more runtime, more capacity than these 3 batteries that you're running. So NOCO makes a really good battery. I didn't include it in the test because it's only an 8 amp hour battery, so it's strong in the factory, but not as strong as any of the batteries in this test. I was using 8000.1 in this test. The battery would have literally played for 5 seconds, maybe less. Not that it's a bad battery, it's just we're overloading what the battery can do. But NOCO battery, really good battery, good factory battery upgrade, good battery if you're running maybe 1,000 watts RMS. Anything bigger than that, you gotta go with a bigger battery. The other battery is the Avant Black battery. So Avant Black makes a battery. My issue with some of these battery companies, and it makes it so confusing because it's like amplifier wattage back in the 1990s. You have companies making these big Surford amps and claiming these huge wattage numbers, and then you look and the amp's got 4 10 amp fuses in it. So it's become the same thing with batteries. So I'm not saying that they're misleading customers, it's just some of the numbers don't make sense. And if Avant Black, if you don't agree with me on this, you could send me a battery, I'll test it and then send it back. But when I went online and checked your specifications, you're claiming, so this is the LIB45. Once again, I'm not saying it's a bad battery, I'm just saying that I think some of the numbers are a little bit exaggerated. You have a 615 cranking amp rating, but you're claiming that you're 576 watt hours for $400, and you're claiming 45 amp hours. So That if your amp hours are correct, that would be the highest amp hour rating out of any battery we tested. The second highest would be 41 amp hours. That battery's $800, so you're claimed to have higher amp hours and be half the price at $400. And then if you look at the watt hours, you're claiming 576 watt hours. Watt hours directly correlate to cranking amps. So if we take the Limitless Nano HD, for example, it has 1800 cranking amps and it's only claiming 384 watt hours. So with 615 cranking amps, you're claiming 576 watt hours. Then we'll look at the Volt Lithium HD41. It's claiming 41 amp hours and it's claiming 563 watt hours. But its cranking amps are 1000. So how do you have 45 amp hours, 576 watt hours, and your cranking amp's only 615? The math's not mathing. So I might be wrong, but you're claiming double the power for half the price. If I'm wrong, send me the battery, I'll test it, and then we'll see if I was wrong, and then we'll send it back. But so the Avant Black battery, I'm guessing that this is a 20 amp hour battery, and I'm betting it's a good 20 amp hour battery. And at $400 for a 20 amp hour battery, I still see value. I just think that the 45 amp hour and the 576 watt hour is kind of crazy when you're admitting that you only have 615 cranking amps. Just so you guys know, the factory Harley battery is 400 cranking amps. So just so you have a reference. So all right, so on with the test. So we tested the Limitless Nano HD V3. We also tested the V2, and we got identical numbers on both. We tested the Volt Lithium HD41. We tested the Braille G30H. We tested the Excess Power LIS 925. We tried to get Excess Power to send us one of their newer batteries, the Titan 8, but I couldn't get anybody on the phone. Concrete Audio, we tested their 5K battery. Concrete Audio is known for making slingshot batteries. They just happen to make a battery that's a drop-in fit for the Harley, but where they really shine is in slingshot batteries. Impact Wiring Solutions. Second volt battery, this is a sodium, the NA20. Then the two we did not get to test was the NOCO NLP30 8 amp hour, $200 battery. And the Avant Black LIB45 power box Harley battery that they claim is 45 amp hour. So the batteries did very, very well. Had to break the batteries up into 3 categories. So we had lithium with BMS, lithium no BMS, and sodium. So any of these technologies will work. You can do audio on any of these batteries. It's just the way the batteries discharge, they're a little bit different. So out of the BMS batteries was the Limitless Nano HD V3 and the Volt Li HD41. So after speaking to Lithium for a long time, and after speaking to Volt marketing for a long time, the batteries are designed differently. So it's actually for 2 different clientele. The Volt battery is designed to last a really, 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 really long time, long parking lot pimp, moderate volume, 2500 watts, 250 amps of current for an extended period of time. The Limitless battery has one of the strongest BMSs I've ever tested, and it's designed to be safe under heavy load. So Even when I talked to the guys from from Limitless, they told me to hit the battery hard and hit it with 1,000 amps and hold it there, that they guaranteed their battery would hold and that the BMS would not trip. I did exactly what they said and they were 100% correct. So for the strongest, highest power, biggest burst, the award has to go to the Limitless Nano HD V3. We hit this with an 8,000 watt amp, held it for 30-45 seconds till we blew the fuses on the power lines going to the amp, and I never tripped the BMS on the Limitless. I also hit it with a 1,000 amp carbon load tester. We hit it 100 amps, 200, 300, 600, 1,000. None of these tests were able to trip the BMS. The battery terminals got upwards of 300 degrees and the battery performed flawlessly. On the Volt battery, I also want to mention that the Limitless Nano, if you register, so if you buy the battery, it's got a 1-year warranty. If you register with the QR code in the battery, it extends your battery warranty to 3 years. We do not let clients leave our shops without registering the battery because I want to make sure every client that buys battery from us has a 3-year warranty. The Volt Li HD41. So they asked us to test it differently. So it's got a 300 amp BMS, so it's not designed like the Limitless Nano is for the burst. It's designed for a long continuous. So they wanted us to test theirs on 250 amp, and we did. So we did a 250 amp load, and we let it play, and we got over an hour of playtime on this battery. So that's pretty impressive. If you're running 2,500, 3,000 watts, and you're playing the battery in the parking lot at full volume, the battery held out really, really long in our test. Cost the same as the Limitless, so each battery is $800 plus the charger. Something that's a little disappointing for me on the Volt battery is they don't make a charger, so they recommend using other LiPo chargers. They said their battery's compatible with most of them. The Limitless offers a charger for their battery. So I like to use the manufacturer's charger with the manufacturer's battery. That way there's no question on whether or not the battery is charged properly. Every lithium failure we have had in the shop is always the battery not being charged properly. So it also helps with the warranty process when the company asks what charger did you use, and you can say we used your charger. But so Limitless Nano HD V3 with the heavy load, high burst, at an $800 retail. If you do the math, it comes about $26 per amp hour if you want to calculate it that way. Battery claims to be a 12.8 volt battery, 30 amp hour, claims to have 384 watt hours, which we confirmed. It claims to have 1,800 cranking amps, which we were also able to confirm. And they rated it as a 6,000 watt battery with 8,000 watt burst. We were also able to confirm we tested on 8,000 watt burst, and we also tested on 1,000 cold cranking amps. So Volt lithium, $800 for the Li HD41. That comes out to, they're claiming 41 amp hour. So that would be $19 per amp hour. They're claiming 563 watt hours and 1,000 cranking amps. So $19 per amp hour that calculates to. So now in the non-BMS, we tested the Braille, the excess power, the concrete audio. These batteries all perform very, very similar. Now, I'm not saying a battery with a BMS is better or not better. That's something for you to decide. Before we started using the Limitless Nano HD V3, we were using another battery which does not have a BMS, only because the Limitless Nano HD version 1 and version 2 were not a factory fit on Harleys. You had to use the adapters. I didn't like the adapters because it brought the positive terminal dangerously close to the ECU under the seat. So we would put foam or tape. It's just, it wasn't a good look, and it wasn't really safe in my opinion. So I talked to the guys at Limitless, and they told me that they would be coming out with a drop-in fit version, and they did. That was the V3. That's why we switched to Limitless. So now we have a BMS, and we have a drop-in fit battery, and you can fit more terminals on the top because there are terminal blocks built in. That's why we started using that battery. But for the longest time, we were using a battery that did not have a BMS. So we never had an issue, never had a battery cap fire, never had a battery explode. Now, I want to remind everyone, in this test, we were doing extreme stuff that you're not supposed to do. At certain points in the video, I had a welder's mask on because I didn't want to risk having, I was afraid one of these batteries was going to explode in my face. The reason I was afraid the batteries going to explode, none of these batteries are designed to have 1,000 amp load on them. 1,000 amps is a lot. During the test, as we set it to 500, 600, 700 or 1,000, the cables on the load tester actually started dancing around from the inrush of current. And the cables are getting hot. They were over 100 degrees. So if you run an 8,000 watt RMS amplifier like we did in the test, the reason the amplifier has 2 0 gauge power and 2 0 gauge grounds is you're supposed to split that load across 2 batteries. I'll be touching more on that on another video I have coming out, because most of these batteries on these bikes are wired wrong. I'll get into that in a later video. So even Limitless, with their super powerful battery, classified as 6,000 watt amp battery, so 8,000 watt amp, even though the battery held it, it's not designed to do that. And when you overload the battery like that, you can risk causing the battery to explode. Now, if the battery explodes, you're using the battery wrong. It's not the battery's fault. I know that I was abusing these batteries and using them in a way that they're not designed to be used in this test. So if I exploded the battery and got hurt, it would be 100% my fault, because I knew going in that I was doing something I wasn't supposed to be doing. So these batteries are rated for between 300 to 500 amps maximum. So that's about 3,000 to 5,000 watts RMS per battery. This test was at double or triple that. So if these batteries had failed during the test, it wouldn't have been the battery's fault. The reason I used such a heavy load during the test is I wanted the test to be quick. I wanted to be able to run the battery down in a couple of minutes instead of over a few hours. So let's say we have done a 300 amp load on music and ran the battery down till the battery went dead. It would have taken hours and hours and hours to run this test. Running an 8,000 watt amp at full tilt for 30 seconds was able to bring all these batteries down. Some of these batteries went down to 2 volts during the test. So it made it easier and quicker. Plus I wanted to test how much abuse these batteries could take. And every single battery in the test passed. None of these batteries exploded. All these batteries are able to be charged. We did damage the BMS on one of the batteries, and the company sent us another one, and then it did okay after that. So now in the non-BMS, so these batteries did well in this test because there's no protection. So the battery would literally give you power and voltage until they physically couldn't anymore, which meant the cells dropped down below 8 volts and the amplifier would shut off, or the cells would explode. Luckily that didn't happen in this case, so we just ran it down until the amplifier shut off. So the Braille G30H, it's rated 12.8 volt battery, 30 amp hour. Battery retails for $714, so that would be $23 per amp hour, and they rate it as a 5,000 watt battery. This battery has no BMS protection. It did really well in the test. It took the full 8,000 watts from the amplifier, and it took the full 1,000 amp from the carbon load tester. Next power battery test was the Excess Power LIS 925. It has a $600 retail. The reason the retail so low, this battery I believe has been discontinued. This battery got replaced by the Titan 8 batteries. This battery uses the adapter post just like the older Limitless batteries. This battery has no BMS, but if you do the $600 versus the 30 amp hour rating, this battery was about $20 per amp hour. It has a 1620 cranking amp rating and a 297 watt hour rating. This battery did really well in the test, and it was one of the least expensive batteries that we tested. Now, one of the most expensive batteries that we tested was the Concrete Audio battery. This battery retailed for $1,000. 12.8 volts, 30 amp hour. Because of the high price, you ended up at about $33 per amp hour. But I don't want you to judge Concrete Audio on the pricing of this battery. They don't really do Harley batteries. They specialize in slingshot batteries, and that's where they really shine. They offer batteries that are a direct fit in the factory tray of a slingshot, and they double the capacitance, so you can get a 10,000 watt battery to slide in the factory tray with no fabrication. I don't know any other battery company that does that. So for a Harley battery, it's kind of expensive. For a slingshot battery, it's actually a really good value. This battery, same as the other two batteries, took the full 1000 amp load test. Did well, did not shut off. Obviously you can't shut off, it doesn't have a BMS, but the battery did not explode, or we still have it hooked up on the test bench and still got voltage, still doing well. Newcomer to the group would be the Impact Wiring Solutions with their sodium battery. It's got a 3-year warranty. It's rated at 12.8 volts. It's rated as a 28 amp hour. This battery did well in the test. It would have did better if I was able to charge it up to 16 volts. I didn't have a 16 volt charger available here in Florida. I have it in New Jersey, so I would have loved to test this battery at 16 volts. Dorian from Blaze Cycle runs these batteries and tests these batteries, and he told me his secret is running these batteries at 16 volts, and it gives him advantage. So on the sodiums, they don't last as long as the lithium, but if you can get them to charge higher, they will give you have the advantage of being at higher voltage, even though it's got a quicker discharge than some of the lithium counterparts. Battery did well. It's got a $580 retail and a 3-year warranty. So that equates, with 28 amp hours that they're claiming, that equates to about $20 per amp hour. The next battery that we tested was the Volt NA20. So it's rated at 12.8 volts, 20 amp hours. The battery is $420 retail, so that equates to $21 per amp hour. Great value. This battery also performed well in our test. We weren't able to test it. It did not supply as much voltage for as long as the lithiums did, and we didn't expect it to, but it still did really well in the test. This is what we would consider a rider battery. So the Volt NA20 would be something for a small audio build. You don't have a 5,000 watt amplifier. You're running maybe a 1200 or a 1600 on your bass. This would be a good battery, and the sodium batteries are more forgiving, so they're less volatile, less of a chance of them exploding, and you can use a regular charger with them. So those are some of the advantages of sodium. Let me check what the warranty is on the Volt battery. Okay, I just confirmed Volt has a 2-year warranty on their batteries. So all these batteries passed the test. They all did really, really well. You just have to pick the battery that's the right fit for you. But we have 2 batteries with BMS, we have 2 sodiums, and we have 3 lithium batteries, no BMS. They range in price from the least expensive battery being $420 and the most expensive being $800. So choose the battery fits for you. Here's a video of the test. Glad I could help. The two Limitless batteries that we tested took a retarded amount of abuse, to the point where I thought that maybe the BMS was faulty and it wasn't tripping. So we actually ran the battery down to 9 volts to get the BMS to kick in, and it did kick in. So the battery is protected. Those BMSs are strong. So the Limitless battery kept up with the non-BMS batteries, which is crazy. But those batteries are built to give you a ton of power and to be abused with big bass amplifiers. So it looks like we tripped the BMS. We're down to 5 volts. Let's see if we can get it to come back on. All right, I'm realizing how vicious that test really was. So we're gonna charge this battery back up and we're gonna go 15 seconds. Cause yeah, I don't wanna blow the woofers and it's 30 seconds a long time. Drew that battery down to like 9 volts. So we're gonna do the same test. I'm gonna keep playing around. We're either gonna go 10 seconds or 15 seconds. Okay, here we go. 15-second test. BMS did not lock up. Oh, there it is. BMS just tripped. So we know the BMS tripped because our voltage is down to 5 volts. That was pretty good. Let's charge that back up and try the next battery. Okay, I decided to give this Volt 41 a second try because 15 seconds tripped the BMS. To be fair, you're not supposed, we're putting 600 amps of current draw on a battery that has a 300 amp BMS limit. So let's see how it does on a 10-second run. All right, give it a second. And we're holding steady at 13.1. Oh, tripped the BMS. So we tripped the BMS at 15 seconds. We also tripped the BMS at 10 seconds. So, let's try it again, 10 seconds. Let me calculate 300 amps. Okay, so in this run, we're gonna do 55 volts, which is around 3,000 watts RMS, which is more in line what a battery this size can handle without tripping the BMS. So let's run it and see if my theory is correct. Come on, don't trip, don't trip, don't trip. And there we go. So we kept the draw at around 300 amps. Battery took it for 10 seconds and we're at 13.2. Let's hit it again without recharging, see what happens. Battery did really well. Dropped down, never dropped below 12 volts. 2 runs, 3,000 watts each. 55 volts AC. And we're at 13.2. Good job. Okay, next up is the Braille. So I decided to run the test the opposite way now. So we're gonna do 10 seconds at 3,000 watts, which is 55 volts AC, and then we'll run it again after we charge it, and we'll do 10 seconds at 70 volts AC, which is about 5,000 watts. All right, voltage dropped down to 11, then it jumped right back up to 13.1. So we're gonna charge it up and then hit it again at 70 volts AC. So I just wanted to make a quick comment while these batteries charge back up. These tests are very extreme tests. These tests are testing these batteries beyond the limit that they were designed to run at. If any of the battery failed during these tests, do not judge the battery harshly because the battery's not supposed to be ran like this. Anything you see them do on tones, they will do double that in music. So if the battery does 3,000 watts on tones, you could easily get 4, 5, 6,000 watts on music because music's dynamic. Tone is just one solid 100% maxed out frequency for the duration. So music is not like that. Music's dynamic. So whatever number you get, you will easily get double, sometimes triple on music. So these batteries have all so far passed this extreme test. So that means that on music, it's definitely gonna work really well for you guys. All these batteries are doing well so far. They've all done above their rated numbers. So the fact that we're even able to hit these batteries as hard as we are explains how far technology's come in the past 5-10 years, because 10 years none of this was possible at all. An 8,000 watt amplifier would not fit on this table. Single battery would not run. You would need a bank of truck batteries to be able to do this kind of power, and the heat would be insane. Even the charger that we're using is small, entry level. I think I paid between $60 and $80 for that charger. Thanks to Josh at Impact Solutions for the recommendation. This thing's awesome. It charges fast. It keeps an eye on the temperature, the charging amperage, and the voltage. Only negative about it is the fan's really loud. But other than that, this thing is awesome. So we're going to be using that charger to charge all the batteries that didn't come with a charger, or the manufacturer does not make a charger. So I figured that would be the most fair way to do it. We will be testing Josh's battery. Josh is the one that recommended this charger, and it works really, really good. But battery's almost charged up. We're about to hit it again. Just realize that these are really extreme tests because I wanted to get to the numbers as quickly as possible. But these batteries are all holding up really well so far. Okay, this is the second run for the Braille battery. We're going to take it up to 70 volts AC, 5,000 watts RMS, 10 seconds. All right, I knew it wasn't going to trip the BMS because the Braille does not have a BMS. So we're at 13.1 after a 10-second run at 70 volts AC. 13.2. Good job, Braille. I decided I want to give the Braille another run to see what it can do, so I haven't recharged it. We're still at 13.2 from the last test. I want to run it for 15 seconds this time at 70 volts AC, 5,000 watts, to see what it'll do. 10.8. Oh, almost dropped the enclosure. So drop down to 10.8. Voltage kick back up. We're back up to 13. 13.1 after recovery. Good job, Braille. Okay, now we're testing the excess power LIS 925. This is an older battery. This is a battery I pulled off of one of my demo bikes in the shop. They've now upgraded to the Titan 8 battery. This is one of the original Harley motorcycle audio batteries. This battery came out, it was over $1,000. This battery is already a couple years old. It's been discontinued. I do not have a Titan 8 to test, but I'm going to show you how good this battery is, and the Titan 8 is as good or even better. So mind you, this battery is a couple years old. It will not charge past 90%, but I guarantee you it passed all these tests. Excess Power builds a really good battery. We'll start with the 3,000 watt test, then we'll go to the 5,000 watt test. We're gonna do 10 seconds a piece. Mind you, this battery won't charge past 90%, and it's still gonna do well. So the battery's recovering. So 10 seconds, 55 volts AC. We're at 13.0, oh, there it is, 13.1. So that's pretty impressive from an old battery. Won't charge past 90%. Let me charge it up and then we'll hit it with 5,000 watts. All right, we're charged back up. We're gonna do 10 seconds at 70 volts AC, so around 5,000 watts RMS. There's the battery recovering. .0. Give it a second. And there it is, 13.1. Great job, Excess Power. Okay, we're testing the Concrete Audio 5K battery. Couldn't get this one to charge above 13. All the other batteries are charging up to about 13.6. We've tested this battery. The guys over at Concrete Audio sent us over the battery to run it through its test, and it's done really well for us. So let's see how it holds up against our 3K test and our 5K test. I think the battery will do well just because of my preliminary testing, but let's see what it does here on this. So 10 seconds, we're gonna hit it 55 volts. Okay, we dropped to 11.2. Battery's recovering. We're at 12.9. It's hanging out around 12.9, so we're gonna charge it back up and then we'll hit it with the 5,000 watt test. Okay, here we go, 70 volt test, 10 seconds. Voltage never dropped below 11.3. Great job, Concrete Audio. So this is the Limitless Nano V2. The reason I'm testing this battery's discontinued, it's no longer current, but the V2 battery from Limitless has been an industry standard for motorcycle audio competition. So Robert, my sales rep over at Limitless, reached out to me a couple of years ago and he was like, hey, how come you don't use our batteries? I told him I do use your batteries. We use them as a tour pack battery because we don't feel that this battery was a factory drop-in replacement, because you have to use the adapter terminals. If you notice, the battery's standing on its side, and then it's got these metal adapter terminals. So with those adapter terminals, in our opinion, the battery wasn't technically a drop-in fit. We do a lot of dealer work, and it's not just them. So even the original version of the excess power was the same thing. So if you notice, you would have to put the adapters to make it come around to the top, because it has to go this way to drop into a Harley. So this is what the battery would have to look like for it to be a drop-in fit for a Harley. So a lot of manufacturers started with this type casing, even Stinger on the AGMs, because with this casing, if you dropped it in this way and then just put an adapter or bent the terminals, it would technically fit. Once they started coming out with Harley specific casings, then the battery started to look like this. So Limitless in the V3 did just that. They moved the terminals to the top to drop in fit. Not only did they do that, but they gave you a nice distribution bus bar on top of the batteries. So I told Robert that if you guys switch to a drop-in fit, then we'll switch from the current manufacturer we're using to you guys, because then for us, these adapters on the top cause issues. The computer for the bike is under the seat and it's dangerously close to the positive terminal. That's why we didn't feel comfortable running these batteries. So once they switched to the V3, it was a no-brainer. We switched over to Limitless because a drop-in fit and it's a great battery and a ton of power. So the reason I want to test the V2 is some people claim that the V2 is better than the V3. I'm all about testing. I like to test. So it's not opinion, it's not hearsay. So let's see what the V2 does, and let's see what the V3 does. So we're going to test it. We're going to run both batteries through identical test. For me, this is considered a tour pack battery. The V3 is a drop-in fit factory replacement or tour pack supplement battery. So for us, it wasn't a power thing, it was a fitment thing. So now we have the best of both worlds. But we're going to run it through the test and see what the V2 numbers are compared to the V3 numbers. So we'll do the 55 volt test, and we'll do the 70 volt test. So 3,000 watts RMS first, and then 5,000 watts RMS, 10 seconds apiece. Drop to 1197. Recovery, we're back up to 13. Mind you, this is a 2-year-old battery. We've been beating this battery up in 2 years. I actually pulled it out of one of my personal bikes. So not bad for a battery, it's 2 years old. Now we're going to charge it up and then hit it with a higher voltage. Okay, now it's time for the 70 volt test. .5 that time. Battery's recovering. 13.0. Did not trip the BMS, even though we've run over the maximum power the battery can take. So if the V2 did that, let's see what the V3 can do. Very impressed. So 2-year-old battery. Took the 3,000 watt test, took the 5,000 watt test. So remember, on the 5,000 watt test, we're drawing close to 600 amps of current on that BMS, and it didn't trip. Went right back, and look at that, we're at 13.1 after letting it sit for a few seconds. Excellent job. All right, here we go, 10 seconds, 3,000 watts. dropped to 12.5. We're at 13.3 recovery, and that's immediate. So I don't know, it's looking like the V3 is better than the V2. Both great batteries, but that jumped back up really, really fast. Let's throw the charger on it and then run the higher voltage. All right, she's charged up, so now we're going for the higher voltage test. So we're doing 70 volts AC, 5,000 watts RMS. Dropped down to 12 volts during the test. I ran it, as you can see, I ran it for longer than 10 seconds. And this battery jumped right back up to 13.6, it looks like. We'll let the voltage stabilize for a second. So it's jumping around from 14 to 13.3. But yes, so I reached out to Robert, and the difference between the V2 and the V3 says is only the terminal orientation. They relocated BMS, so the batteries are identical. They're literally the same battery, same everything. So there we go. So we finally rested at 13.3, 13.2. It's going up 13.4. It's really amazing. So he said there's no difference between the battery chemistries. So for you guys that are saying the V2 is better than the V3, it's now the reason the numbers aren't exactly the same is this V3 is brand new. My V2 is a little bit older, but they both did well in the test. Resting voltage on this one's a little bit higher. I'm gonna hit this one again without recharging it to see if we can get the BMS to trip. Okay, so I want to see if I can trip the BMS on this battery. I haven't charged it, so we're at 13.2. When we charge it, it ends up at like 13.4, 13.5. So I want to see if I can trip the BMS and get the battery to shut down. So let's see how much voltage that takes. Hopefully I don't blow the woofers. So the amplifier shut off. Looks like we got up to about 89 volts. Hopefully I didn't break the amp. Let's take some voltage readings. I'm going to keep the camera rolling to see what went on. All right, 4.7 volts, so we tripped the BMS. I don't know why I'm getting a false reading on the other meter. No, we're at 13. Oh, maybe we blew the fuses. Oh, there we go. We destroyed the fuses. Blew both of them. So the battery survived, the fuses didn't. There we go. So we were at 7,900 watts RMS. The woofers held up, the battery held up, the fuses did not. So sounds about right, because we were in excess of 400 amps for more than 10 seconds. So the math is definitely mathing. We're a little short on current because we're only running one battery. So the fact that the fuses blew makes 100% sense, because at 8,000 watts, we're drawing 700 amps of current. fuse are rated for 400 amps. We exceeded it for over 10 seconds and the fuses failed. So that's 100% correct. And we're still at 13.2. Excellent job. Okay, so now we're running the same test, but with a different category of batteries. These are the sodium batteries. So we have the new kid on the block. This is the impact wiring solutions. Actually, both sodiums are new kid on the block. We have the impact wiring solution and we have the volt. So the volt is 20 amp hour. Impact wiring solutions a 28 amp hour. Let's see how they perform against each other and then against the lithium batteries. So benefit to sodium batteries is you can use any charger on them. You can jump the battery. You can't jump lithium batteries. And they have, if you can get the battery to charge up, the higher the voltage you get it to charge, the more usable bandwidth, we'll call it, of the battery you get. So with lithium can take more of a large discharge and maintain it for a longer period of time. Sodium can't. The sodium drops off quicker, but the sodium is able to charge up higher. So if you have the capability to charge the battery to 16 volts, then you get the extra benefit of being a full 2 volts higher when you start. So even though it discharges faster, if you start at higher voltage, it has the ability to play longer. Where we see a real benefit to the sodium batteries is on anything with an alternator. So for us, it would be slingshots. So anything backed by an alternator, you're able to charge at a higher voltage, and the alternator can help the battery stabilize the voltage through a wider bandwidth. But let's see how the battery does. Let's see how long it holds up, and see if this is the right application for some of you out there. Sodium is technically a safer technology than lithium, but let's see how the battery does. So first test, 10 seconds, 55 volts AC. Battery's doing well, so I held it a little bit longer. So give that about 15 to 20 seconds. And let's see how it recovers. Wow, 14.4. I'm impressed. So it doesn't look like it needs to be charged, but to give it a fair shake before we hit it with the 5,000 watts, let's charge it back up. Okay, while we're letting the battery charge up, I want to take a moment to thank Josh at Impact Wiring Solutions. So everyone that sent me a battery to test, I asked them what their recommended charger was, and especially if the battery didn't ship with a charger. So obviously we're using the Limitless charger on the Limitless battery, we're using the Braille charger on the Braille battery, excess charger on the excess power battery. So this is a good all-around charger. This is a charger that Josh recommended to me, Josh from Impact Wiring Solutions. So it's $60 on Amazon. I chose the 20 amp version. They make a 20, 25, 35. So he recommended a 20 amp version. I used a 20 amp version. As you can see, I just got it this week. It does lithium, AGM, and it does LiFo 4. It's got a repair mode. So we've been using it to charge all these batteries in between runs, just to see how well the charger works. A, it charges really fast. B, it lets you know the temperature. So right now we're at 14.6 volts charging, 3.8 amps charging, and 89 degrees Fahrenheit. That's the information I just got from the screen of the charger. Works really good. We've charged the batteries about 10-15 times already. You can see our charge rate of 14.5 at the battery. The charge rate is 14.6 at the charger, so that's accurate. Good little charger, inexpensive. So I recommend. It's worked well on all these batteries. It automatically shuts off. So when the charger shuts off, you'll look on the screen, it'll say full. So good little charger. $60 is the cheapest I've seen any decent quality charger go for. So thanks, Josh. And it looks like we are almost ready to run this test again. Sorry, forgot to give you the name of the charger. It's an HTRC 20 amp smart battery charger. It's $59.99 on Amazon right now for the 20 amp version. $63 for the 25 amp version and $110 for the 35 amp version. So HTRC 20 amp smart battery charger. All right, here we go. We're doing a 70 volt test this time. Obviously longer than 10 seconds. Battery voltage dropped down to 12.1 at its lowest, and it jumped back up to 14. Amazing job. Recovered back to 14.1. Great job. So since the battery did so well, we're going to jump up and push it. Let's go 7,000 watts, see how it does. I don't want to blow the fuses again like we did on the Limitless test, so let's see. Looks like it's going to be 83 volts. Yep, so 83 volts. We're not going to charge it. Let's see how well it does. We're not going to time it this time. We're just going to go up to 83 volts and then back it back down. $11.7. It dropped down to, jump right back up to 14. So battery does what it's supposed to do. So he's got this battery rated at 5,000 watts. We just tested it 7,000 watts for a few seconds, and it took it like a champ. Did not trip the BMS. Good job. Guys, do yourself a favor. If you're going to be ordering these batteries running high power, do not use the bolts that came with the battery. Some of these batteries came with the right bolts, but 90% of them came with the wrong bolts. So I don't want to pick on anybody, so I'll just say, Phillips head, no good. The Phillips head with the hex head that comes from Harley is also no good because it has a flat washer on the bottom, so it's really easy for the terminals to get loose. If you see how this one's all discolored, it wasn't 100% tight, and when we ran it through the 500 amp test, the bolt actually turned cherry red. So having a smooth surface on the bottom is not a good idea because you're putting it on ring terminals that are also a smooth surface. This is what we recommend. This is a flange head M6, all these batteries are M6, flange head M6 bolt. It has teeth on the bottom, so this keeps the bolt from spinning out. The length is 12 millimeter. So M6, flange head, 12 millimeter. You can actually get an assortment on Amazon. So 10 millimeters if you're only gonna have 1 or 2 ring terminals. You have to go longer if you're gonna use more. So you can get this assortment on Amazon. It's 20 bucks. And all you have to do is search for flange head M6 bolt. So if you want to take a screenshot of that, every single battery, even when we do the factory Harley batteries, we replace the bolt with these. M6 flange head. If you're only going to get a couple, get the 12 millimeter long. It makes a huge difference. Keeps the, so once you tighten it down, the terminal's not going to come loose. If you use this style, after you tighten it, if you just wiggle it with your hand firmly, you will shake the terminal loose. With these, it's a super tight connection, will not let the terminal come loose. Okay, we have the volt power, Na20, sodium, 20 amp hour. We're gonna do the 55 volt test first. Drop down to 10.6. Jump right back up to 13. Very nice. So we're going to charge it up a little bit, and then we're going to hit it again with 5,000 watts, so 70 volts AC. All right, we're charged up. See, let's get it up to 70 volts. Drop down to 8.8 volts, which shut the amplifier down for a second. So we let it recover. We're at 12.7, gonna hit 12.8. There it is, 12.8 on recovery. All right, so not bad. So we hit this battery with 5,000 watts, 70 volts. That was the limit. The battery dropped down to 8 volts. Once we backed off, it jumped right back up. So we didn't trip the BMS. I'm sure we came close. We didn't trip the BMS, but nice little run. Good job. Okay, so I just reached out to both companies, Volt Power and Impact Wiring Solutions. I misspoke when I said the batteries had BMS. Neither of these batteries have a BMS because of the safer sodium technology. They both have balance boards. So the reason it didn't trip the BMS is there is no BMS. So both batteries did well. Both batteries took the 5,000 watt test, and both batteries recovered. And we're still sitting at 12.9 volt on the Volt battery. All right, for this test, first we're gonna hit 100 for 10 seconds, then 200, then 400, 600, 10 seconds apiece until the BMS kicks in. I got 100 amps, voltage dropped to 2.24. Now we're going to kick it up to 200 amps. 200 amps, 11.5. We're at 300 amps, 10.8. 400 amps. Battery terminals are at 80 degrees. We're going to go up to 500 amps now. 500 amps. 9.4 volts. BMS should be kicking in any second now. That's 10 seconds. Let's push it to 600. 600. 8.3. 10 seconds, we'll back it off. And the BMS never kicked in. Terminals. We got a maximum voltage of 96 volts. Battery's recovering. Terminals got hot. That's really, really, really good. So that was a Limitless Nano V2. Let's try the V3 now. The reason we're using the Limitless adapter for all the batteries in the test is just so we can get more surface area, because this is what happened when we sent power to the screws that came with the battery. Some were turning cherry red hot because we're trying to run 500 to 1,000 amps through the screw. So now that we're using the adapters, it spreads the current across the entire area and the surface of the battery. So the Limitless adapter will make it a fair test across all the batteries, because they're all going to have good clamping force. So we're going to be using these on all the other batteries, on the Braille, on the impact wiring, on the Volt. All right, so we're going to start at 100 amps. This is the Nano V3 by Limitless. 100 amps. We're going 10 seconds. We're at 12.6 in the voltage. And that's 10 seconds. So now we're going to go to 200 amps. We're at 200 amps. We're 11.78. We're going to jump all the way up to 400 amps. We're at 400 amps. We're at 10.58. That's 10 seconds. Then we're going to go to 600 amps. 600 amps. We're at 9.2. This should trip the BMS. We're at 10 seconds. Then let's kick it up to 1,000 amps. So we're at 1,000 amps. Battery voltage is at 6.8 volts. I'm gonna drop it down. I don't want to destroy the battery. So now the battery's recovering. How low did the voltage drop, Josh? Okay, the voltage dropped to 7 volts. And we hit a terminal temperature of 108 degrees Fahrenheit. Battery's recovering nicely. We're at 13.1. 13.1 after being hit with a 1,000 amp load. That's amazing. All right, let's move on to the next one. Cable. So the cable hit 135 degrees. It's a serious test. And we just jumped up to 139 degrees. All right, let's move on to the next. 105. Right. So now we have the Volt Lithium HD 41. So we're gonna hit it with 100 amps first. Then every 10 seconds, we're gonna go up. Let me get my stopwatch ready. All right, so here we go. We're at 100 amps. Voltage is at 12.2. Going to 200 amps. Voltage is at 11.3. Going to 300 amps. 300 amps. Voltage is at 10.3. Going 400 amps. 400 amps. Voltage at 9.4. I expect the BMS to trip now. And there it is. Battery terminals are at 83 degrees. So BMS is 300 amps. It took us all the way up to between 400 and 500 to trip it. So battery did what it's supposed to do. Let's switch the charger on and see if we can get it to come back. We'll let it rest for a second, see if we can bring it back online. All right, impact wiring solutions. We're starting at 14.2. We're gonna hit it 100, 200, and we're gonna gradually go up. There's 100 amps. 13.2, hold it steady. $200 amps. 12.31. 400 amps. 10.4. 600 amps, 7.4, 600 amps. 600 amp, 5 volts, so we'll stop the test. Battery came right back. 12.6, very impressive. 600 amp load for 5 seconds. So let's go all the way back up to 600 amps, see if we can get 10 seconds out of it. Now it's recovered back to 13 volts. .600 amps, voltage of 8.6. .10 seconds, 7.7 volts, very impressive. All right, next battery, and the temperature, 98.6 at the terminals. All right, volt sodium Na20. See how it does. Amps, 12.4 volts. Kicking it up to 200 amps. 10.9 volts. And kick it up to 400 amps. 7 volts. 6.8. Recovery right back to 12.4. Hit 8.7 degrees on the terminals. Let's hit it one more time. 600 amps this time. 6.6 volts. Recovering. $90 degrees on the terminals. Recovered back to 12 volts. Let's try 600 volts, 600 amps one more time. .4 volts. .100 degrees on the terminals. Covering, we're at 11.11. 98 degrees. 11.2. Good job on the salt. All right, it's the Braille's turn. .100 amp, 214 volts. And jump it up to 400 amps. .45 volts. Let's go to 600 amps. .8 volts. Let's hold it there for 10 seconds. Awesome. Jump back up to 12.8, 12.9, 13. All right, let's hit it at 1,000. 1,000 amps, 5.5, go for 10 seconds. Now those terminals have to be blazing hot. .102, 104, 107. Yeah, I knew it was gonna be hot. It's a lot of current. 111 degrees at the terminals. Look at that battery jump back up to 13. Good job on the Braille. Okay, called our friends over at Concrete Audio and asked them if it was okay to hit this battery with 1,000 amps. And they say, go ahead, it will take it. So here we go, we're at 14.6. We're gonna skip over the 100 amp, we're gonna go straight to 400 amp. Amp test. 11.5. Holding. Now we're gonna jump up. Let's hit it with 1,000 amps. Didn't quite make it. So 1,000 amps was kind of ambitious. Voltage came back up. So this battery's rated at 5K, so let's hit it at 600 amps, which is more than 5,000 watts. 600 amps, 9 volts, holding. Ten seconds. It took it. Watch these power cables when we hit it. Watch them twitch. See that? That's how much current is flowing through those cables. Voltage back up to 12.7. Excellent. Battery terminal's getting nice and hot. 98 degrees. And look at that healthy voltage jump back up to 13.2. So let's hit it again, 600 amps. Nice. So this battery can take abuse. Look at that. Back up to 12.7. It's still climbing. 12.8. 12.9. 13 volts recovery. Let's hit it 800 amps, see what happens. This is why these batteries do so well in the slingshots. 800 amps, voltage dropping way down. 5 volts. Voltage dropped right up, 12.3. And those battery terminals getting hot, 108 degrees. 110 degrees. And the voltage jumped right back up. Great job, Concrete Audio. This battery is only rated for 5,000 watts. We hit it over 600 amps, so 600 amps is over 6,000 watts. And then hung out 800 amps for a little bit. This is a tiny ass battery too, it's smaller than these batteries. Cables on the tester are getting hot. Tester cables, almost 130 degrees. And look at that. Battery, 12.9. Great job. So I want to remind you guys as I'm testing these batteries do not have a BMS. So when I'm hitting these batteries this hard and the terminals are getting hot, the batteries do run a risk of exploding. So you got to be careful. What I'm doing here, I would never do on a customer's bike. This is just a test to see how far we can stretch these batteries and see how well built these batteries are and what we can get away with. The batteries with the BMS are much safer. So that would be the Volt battery, the Volt lithium, Limitless lithium, the only 3 batteries in the test have a BMS. So all these others, so these batteries will shut off once you overdrive past whatever they designed them to run at. Once you pass that, the battery will shut down. These batteries are taking a beating and giving us a buttload of current output, but no safety built into the battery. So you have to be super careful hitting them this hard, that's how you get batteries to explode, because we're literally overloading. So this is telling us that it's a 5K battery, which means we should not exceed 500 amps of current, yet we're testing at 600 amps, 800 amps. So same thing with the excess power. Same thing with the impact battery, same thing with the volt sodium, and same thing with the Braille. Leading cause of battery failure and batteries exploding is not using the correct charger. This is the big boy Braille charger, 50 amps. That's the excess power charger, 25 amps. This is the smart charger recommended by our friends over at Impact Wiring Solutions. We have our snap-on lithium charger. We have the newer style Braille charger here. We have the Limitless maintainer. I wouldn't call this a charger, it's a maintainer. We also have the big boy, this is a 3 amp. We also have the big boy 25 amp. Let me make sure. Yep, this is a 3 amp. We also have the 25 amp. We have the NoCo Genius. We have the C-Tech. So over the years, I've spent a ton. I've spent thousands of dollars on chargers to make sure I have the right charger with the right battery. These are all similar, but they're all a little bit different. They charge differently. The newer ones have a recovery mode, so it pulses the battery and it doesn't just hit it with straight voltage to allow the lithium to build back up. But it's very important to use the right charger with the right battery. Using the wrong charger or overcharging the battery is the leading cause of lithium battery failures and explosions. Okay, now it's time for the excess power. We're gonna go right to 400 amps. All right, drop down to 8.8 volts. That's 10 seconds, we'll drop it back down. Recovery, nice. Mind you, this battery's 2 years old. Bam, 13. So then we'll see how far we can go. Let's see if we can hit it with 800 amps. Dropping. Yeah, we're down below 5 volts. See if we can hold it there 10 seconds. This definitely exceeds the battery's capabilities. But there we go. 800 amps, 10 seconds. Let's see if it'll come back. Wow. See smoke coming off the terminals. (102 degrees at the terminals. And back up to 13. Now remember, these batteries do not have a BMS. (1,000 amps, 4 volts. Whoa. I think we just killed the battery. Heard something pop. Wow, look at that. Hey, it came back to 13 volts. There's definitely something broken. I heard something pop in the battery. But holy cow, can that battery take abuse. Super impressed. Good job, excess power. battery cable is not liking it. 136 degrees. Battery still testing good. What a champ.